Dichlorodifluoromethane is a colorless gas usually sold under the brand name Freon 12, and a chlorofluorocarbon halomethane used as a refrigerant and aerosol spray propellant. Complying with the Montreal Protocol, its manufacture was universally banned in 1996 due to concerns about its damaging impact to the ozone layer. Its only allowed usage is as fire retardant in submarines and aircraft. It is soluble in many organic solvents. Dichlorodifluoromethane was one of the original propellants for silly string or 12 cylinders are colored white. Preparation: it can be prepared by reacting carbon tetrachloride with hydrogen fluoride in the presence of a catalytic amount of antimony pentachloride, CCl4 plus 2HF or CCl2F2 plus 2HCl. This reaction can also produce trichlorofluoromethane, chlorotrifluoromethane and tetrafluoromethane. History: Charles Kettering, Vice President of General Motors Research Corporation, was seeking a refrigerant replacement that would be colorless, odorless, tasteless, non-toxic, and non-flammable. He assembled a team that included Thomas Midgley, Jr., Albert Leon Henn and Robert McNary. From 1930 to 1935 they developed dichlorodifluoromethane, trichlorofluoromethane, chlorodifluoromethane, trichlorotrifluoroethane, and dichlorotetrafluoroethane through Kinetic Chemicals, which was a joint venture between DuPont and General Motors. Use as an aerosol: the use of chlorofluorocarbons as aerosols in medicine, such as USP-approved salbutamol, has been phased out by the U.S. Food and Drug Administration. A different propellant known as hydrofluoroalkan, or HFA, which is not known to harm the environment, was chosen to replace it. Retrofitting: R12 was used in most refrigeration and vehicle air conditioning applications prior to 1994 before being replaced by 1,2-tetrafluoroethane, which is an insignificant ozone depletion potential. 1992–1994 was the time period in which automobile manufacturers started using a 134A instead of a 12. When older units leak, retrofits to a 134A are recommended. Retrofit to a 134A requires complete flushing and filter dryer replacement to remove the mineral oil. Mineral oil used for a 12 is not compatible with our 134A. Some oils designed for conversion to a 134A are advertised as compatible with residual A12. New rubber hoses which are a 134A compatible may be needed for the same reason. In systems where a 134A is not practical, an A409A blend may be directly added to an A12 system without changing the oil, although a filter change is always recommended. R409A usually runs on the low-pressure side of the system at 12 pounds per square inch, while A12 usually runs on the low side at 10 psi. R409A runs at higher pressures and is less efficient but works quite well. Manufacturers recommend that the existing R12 charge be recovered. However, as the two refrigerants are soluble in the same mineral oil, there are no complications associated with mixing them. Note that the instructions for R409A recommend charging a system with liquid to keep the mixture ratios constant. The constituents have varying vapor pressures. Gallery. References. External links: NOAA-ESRL-CFC12 Global Measurements, International Chemical Safety Card 0048, Overview of Freon 12 and some of its environmental problems, MSDS at Oxford University, Thermochemistry Data at ChemNet.ru, IR Absorption Spectra, CDC, NIOSH Pocket Guide to Chemical Hazards.